Today, derivatives of inverse trig functions. So you already know the derivatives of all the trig functions and a handful of other things, but what about this bunch of stuff down here? Well, today I'm going to show you where this all comes from. Okay, so of course the important thing in this particular context that we're in of the class, you really just need to know the results. But the derivations are interesting and important, so I'm going to go through them, at least some of them, and invite you to go through some of the other ones. All right, so we're going to start with if y equals inverse sine of x. All right, and so what is dy dx? So the first thing you have to do is understand what an inverse function is. So an inverse function means I exchange the roles of the x and the y. So y equals inverse sine of x really is to say that the sine of y is equal to x. That's what y equals inverse sine of x means. Of course, with the trig functions, there are some tricky things about how the domain is restricted, but fortunately, it's not going to impact most of our derivations here. All right, so now what we're going to do is we're going to see, this is why you learned implicit differentiation. So you can differentiate this implicitly. I could solve this for y, but it would just take me right back to where I was. So the idea is, could I find the derivative without solving for y? And implicit differentiation gives you the ability to do that. The derivative of sine is cosine. That's the derivative of a function in y with respect to x. So we put a dy dx, and the derivative of x is 1. So this is what I get doing the derivative with respect to x on both sides of this equation. All right. Then my next step is get dy dx on the left. Well, I already did that. And then so now we're just going to divide. So we're going to have dy dx equals 1 over cosine y, also known as secant of y. All right, well, but I'd like my dy dx to be in terms of x instead of being in terms of y. So what we can do now is just plug the y back into it. So we know that y is inverse sine of x. So I have secant of inverse sine of x. So the next thing that we're going to look at is, how do you get from this, the secant of the inverse sine of x, to this 1 over square root 1 minus x squared? So there's a really crucial technique that we can use to do that. And that technique is like this. We're going to analyze, and this is useful anytime you have a trig function of an inverse trig function, but the two functions don't match. Right, if it was sine of inverse sine of x, then they would just cancel out and it would be x. Of course, you'd have a domain restriction, but we won't worry about that. Since it would be the same domain restriction as the original function. All right, but these two functions don't match. So how are we going to simplify these two functions? Well, so an interesting way to do that is to draw a triangle. So we're going to draw a nice right triangle, and we're going to say, all right, let's have an angle here called theta, and theta will be the inverse sine of x. All right, so remember that when we say the inverse sine of x, we mean what is the angle whose sine is x. So we're really looking for an angle, so we're going to call that theta. So what this means, again, using this type of transformation, which is really important to think about when you're thinking about inverse functions, the meaning of theta equals inverse sine of x is that the sine of theta is equal to x. Okay. Now I can use this fact to start filling in my triangle, because the sine of theta is opposite over hypotenuse. All right, and so I know opposite over hypotenuse equals x. So now I know what the opposite and the hypotenuse are, because x is equal to x over 1. So I can say the opposite angle is x and the hypotenuse is 1. Then I can use Pythagoras' theorem to solve for the side down here. Why don't you go ahead and use Pythagoras' theorem to solve for the side down there? Okay, so I hope that you got square root 1 minus x squared. That's not too hard to do, so you should do that. If you have trouble with it, let me know. All right. Now, so that's what this is. That inverse sine of x is really, well, is that what I want to say? The inverse sine of this theta, this angle that we have here, this theta is what the inverse sine of x is. Okay, so now what we need to know is what is secant of theta. What is secant of theta? So all right, secant is 1 over cosine. And so it's going to be hypotenuse over adjacent. All right, well, I just look at the triangle. Here's theta. Here's the hypotenuse. Here's the adjacent. So I get 1 over square root 1 minus x squared. So that is what secant theta is, and theta is inverse sine of x. So secant of inverse sine of x equals 1 over square root 1 minus x squared. And since that's also what dy dx is, then we also have our dy dx equals 1 over square root 1 minus x squared, which is exactly what you see here. All right, so let's go ahead and throw one more in here, which is I have y equals inverse cosine of x. And now what's dy dx? So once you get this, you're going to start to see that you can do all the inverse trig functions the same way. So first we're going to rewrite it cosine y equals x. Derivative of cosine is negative sine, so negative sine y. Dy dx for the chain rule equals 1. This is derivative with respect to x on both sides. So dy dx equals negative cosecant of y. And since our y was inverse cosine of x, that equals negative cosecant of inverse cosine of x. All right, now I'm going to leave it to you to draw the triangle the way we did in the last one and see if you can come up with what this simplifies to. But we already know that it's going to simplify to negative 1 over square root 1 minus x squared. All right, so I'll let you do the triangle and show why this is the case just on your own. I'm not going to collect it or anything. It's just an exercise. All right, and then we'll start looking at the next ones.